Hello guys, welcome to Sapima tutorial. Today we'll be looking at this bearing problem before us. A man starts a journey from A and walks 2 kilometers on a bearing of 017 degrees. He then walks 3 kilometers on a bearing of 107 degrees to C. What is the bearing of C from A? Alright, so the angle we shall be looking for will be the angle at A, because they say from A, the movement will be at A. Okay, so the first thing we do is to produce the diagram for this problem, because you don't solve bearing problem without a diagram. Now, a movement started from the bearing of 017 degrees. 017 is in the first quadrant, so we produce our cardinal point at this place. All right, take note that every movement starts from the northern pole. So from this pole, we move a little, turn a little, and go up. All right, the movement will be in this direction. Produce another cardinal point here. Record that here is A. The man from this position changes direction in this bearing 107. All right, so 107 will be found on this quadrant, the second quadrant here. From here to somewhere a little into the second quadrant will give us the line of movement. Okay, now this line will be a little longer than this because this one is 2 kilometers. Then we produce our cardinal points where he stops. Now this place is my C. We can join the diagram from here. Discover that this one is a little above the first cardinal point, because this line is tending towards the eastern pole, which is this pole, the eastern pole, because it's just 17 degrees away from the eastern pole, because 107 minus 90 degrees from here to here is 90 degrees will give me 17 degrees. So here, this space here is just 17 degrees, so it will be close to the eastern pole. That is why this one is a little above from this one. Now we join the line. Take note that this movement is not on this line. This is the eastern line, so it is a little above it, and this one is not on the western pole, it is a little under it. Okay, recall that we are looking for the bearing of C from A, so we are looking for what angle will somebody move if he wants to go to C from A. So I will come from here to here before I will now move on this line to get to C. So we are looking for the angle from this place and this place. So I have been provided with the angle here as 17 degrees. I will need to find the angle at this position. If I find it, I will add it up to this one to give me the total angle of this movement. Okay, let's consider that values given to us. I will help us find this angle. Since here is 17 degrees, here will also be 17 degrees because they are alternate. This line and this line are parallel. This is transversal, so they are alternate. Now recall that from here to here is 107, so I can quickly get the angle here. If I say 107 minus 90 degrees, I will have here as 17 degrees. That means 90 minus 17 will now give me the angle here, because from here to here is 90 degrees. So here will be gotten by removing 17 from 90, which will give me 63. All right, so here is 63. Then the total angle at this position, add these two, you have 80. All right, so we need this angle here to help us get this angle we are looking for. Now let's consider whether we are using Pythagoras theorem, cosine rule, sine rule, or trigonometric identity. You can check up on my page for the conditions for using each of these parameters to solve triangle. I've treated it. It is on my page on my YouTube channel. All right, so to get this angle, I have the side facing it, which will help me get this angle, and I need another angle and a side facing that angle. This is the only angle I have, but no side is facing it. So my first business is to get this side facing this angle to help me solve for this angle. Now to solve for this side, I have an angle here flanked by two sides provided. Now if I have an angle, included angle in a triangle, included angle in the sense that two sides are given and an angle is in between the two sides given, then we are using cosine rule to solve. The label here B, so we have ABC. Now because we are looking for the side facing B, we'll say B square is equal to A square plus C square minus 2 AC cos B, which is the angle here. So we use this cosine rule to get this side. Then with this we can get this angle. All right, now B square is not given. We continue with B square. B square is equal to my A. is the side facing A, which is 3 kilometers. So 3 square plus the side facing C, which is 2 kilometers, minus 2, 3 and 2, plus my B is the angle at B, which is 80 degrees. Then you can point your calculator at this point, one after the other. Here first, 3 squared will give me 9, 2 squared will give me 4, minus 2 times 3 is 6, times 2, 12. 12 cos theta, we press our calculator. 12 cos 80 will give me 2.0837. Add this and subtract this one. 9 plus 2 is 13. 13 minus this is giving me 10.9. Now record that we are solving for B. So take the square root of the both sides in order to eliminate the square from B. So I'll have B to be equal to square root of 10.9. I'll now have 3.3. We can approximate it as 3.3 kilometer. Now, having gotten here as 3.3 kilometer, I can now solve sine rule to get the angle at this position, because I have side facing the angle I'm looking for, and I have another angle provided to help me, and the side facing it has been provided, which is this side. So I can comfortably solve for sine rule, and sine rule states that A over sine A is equal to B over sine B equal to C over sine C, depending on the side you are looking for. All right, we use 2 at a time depending on what is provided on the triangle. So we are solving for A and we are using B to get A. So we are using sine A and sine B. So since I am looking for angle, I can use the reciprocal of the information, that is sine A over A equal to sine B over B. The angle at A is theta and the angle at B is 80. The side facing A is 3 kilometers. The side facing B is 3.3 kilometers. Let us put all the information in the formula. So I have sine theta over 3 equal to sine 80. The angle at B is 80 over 3.3. Then make sine theta the solid formula by cross multiplying. I'll have sine theta to be equal to 3 sine 80 over 3.3, making sine theta the solid formula. So I'll have sine theta as, point your calculator to get these values. I'll have 0.8. Now to get theta from here, theta is gotten by saying sine inverse of this value. You press your calculator, shift sine, and then press the value. I will have my theta to be equal to 63 point. So we can approximate it to the nearest degree. I will have 64 degrees. Now, having gotten the angle at this position as 64 degrees, to get the bearing of C from A, that means we are moving from here to here, we will add. We will now say that the angle at A is equal to 17 plus theta, which is 17 plus 64. And this is giving me the angle at A as 81 degrees. Thank you very much for coming on board. Please do not forget to subscribe to my page, like my videos, and share my videos to your friends. Thank you very much.